Good morning. My name is Dr. K. Lalitambike, working as Assistant Professor, Department of Physics, KSR, College of Engineering, Tiruchendur. In this video, we are going to see the necessary condition to achieve the population inversion. Already we have seen what is laser and the principles. So this is the continuation of previous video. If we consider two energy states, one is the ground state and another one is excited state. N1 is the number of the atoms present in ground state and N2 is the number of the atoms present in excited state. Let us consider it is a situation in which the number of the atoms in higher energy state is more than that in the lower energy level. Usually at thermal equilibrium condition, the number of the atoms N2 at higher energy level is much lesser than the number of the atoms at lower energy state N1. It means N1 greater than N2. But we need more atoms in excited state. If more atoms present in higher energy level means they can easily stimulate and it emits 2 photons. So more number of emitted photons form and strongly produced as laser beam. So the state of achieving more number of atoms in higher energy state than the lower energy state. It means N1 lesser than N2. This is called as population inversion. So some conditions have the population inversion. That is, there must be at least two energy levels and E1 and E2. There must be a source to supply the energy to the medium. It means external force will be given by using any suggested methods. Then the atom must be continuously raised to the excited state. Now we are going to see the laser action and necessary condition to achieve the laser action. Before seeing that, we must know the Einstein coefficients A and B. Einstein's theory of absorption and emission of light by an atom is based on Planck's theory of radiation. Also under the thermal equilibrium condition, the population of energy levels obey the Boltzmann distribution law. At steady state of rate of the absorption is equal to the rate of the emission. So simplify this equation. It means number of the upward transition is equal to number of the downward transitions. We simplify this equation by using Boltzmann distribution law and Planck's radiation formula. Finally, we get Einstein coefficients A and B. Here, B21 is spontaneous emission and A21 is stimulated emission. The spontaneous emission is more predominant than the stimulated emission. Therefore, stimulated emission should be greater than the spontaneous emission. It means the number of the atoms in excited state can be made more than the number of the atoms in the ground state only under the negative temperature. But the negative temperature is practically impossible. Therefore, population inversion can be achieved by some other artificial process we called as bumping process. Bumping methods. For artificial bumping methods, we must need the active medium and active center. Active medium means the medium in which the population inversion takes place. Then active center means the material in which the atoms are raised to excited state to achieve population inversion. So the process of raising more number of the atoms to excited state by artificially, it means we simply say bumping methods. The methods commonly used for bumping action are optical bumping and electrical discharge method, inelastic collisions between atoms and direct conversion method. We are going to see one by one in detail. Optical bumping method. For optical bumping, here uses flash lamps and high energy light sources for bumping process. Where the atoms are exposed to light radiations of energy, the atoms in the lower energy state absorb this energy and go to the excited state. This is the optical bumping. It is used commonly in solid state lasers like ruby lasers. Then electrical discharge method. In this method, the electrons are produced in an electrical discharge tube. These electrons are accelerated to high velocities by a strong electrical field. Now, accelerated electrons collide with the gas atoms during the collision of the energy of the electrons. So, the electrons is transferred to the gas atoms. Therefore, atoms gain energy and go to the excited state. This results population inversion. So, in this method of bumping is used in gas lasers like carbon dioxide laser or gun. Then, inelastic collisions between atoms method. So, atoms exchange their energies with other by inelastic collisions and get excited due to additional absorbed energy. Example, helium neon laser. Then we can see direct conversion method. So in this method, electrical energy is directly applied to bandgap semiconductor like gallium arsenide. The recombination of electrons and holes takes place. During the recombination process, the electrical energy is directly converted to optical energy as laser beam. So this is used in gallium arsenide semiconducting laser. For achieve the laser action, we must know the optical resonator. It consists of active medium kept in between a 100% of reflecting mirror and a partially reflecting mirror. It acts as a feedback system in amplifying the light emitted from the active medium by making it undergo multiple reflections between the 100% of mirror and the partial mirror. Here, the light bounces back and forth between the two mirrors and hence the intensity of the light is increased enormously. Finally, the laser beam comes out through the partial mirror. So, we can simply explain the photon emitter during the stimulated emission. So, it has same energy, phase, frequency and direction as like incident photon. So now we have two covalent photons. Now these two photons incident on two other atoms in the higher energy state. This results induced emission of two more photons by reflecting mirrors. So there are four covalent photons have same energy. These four photons induce further transition with the other four atoms by reflecting mirrors on both sides. This gives 8 covalent photons. If it continues, finally we get strongly high intensity of covalent beam. So we get this light is called as laser. So for the laser action, stimulated emission is very important and it is achieved by population inversion. Based on the type of active medium, the laser systems are classified by solid state laser, example ruby laser, then second one is gas laser, example carbon dioxide laser, third one is liquid laser, example cerium oxide chloride, fourth one dye laser, example rhodamine 6G laser, fifth one is semiconductor laser, example gallium arsenide laser. Additionally, we see the levels of lasers. It is known as 2-level and 3-level and 4-level lasers. 2-level lasers mean it has only two energy states. One is ground state and another one is excited state. Then 3-level lasers. It has three states. There is ground state, excited state, then additionally metastable state. Here, the laser transition occurs in between metastable and ground state transitions. In 4-level lasers, it has ground state, excited state, metastable state and additionally lower level state. So the laser transitions occur only between metastable state and lower level state. Then finally we see few applications of laser in different fields. In commercially used as laser printer, laser pointers, then CD and DVD writing, etc. Then industrial applications. So especially the material processing. So the material processing involves laser welding, laser drilling and laser cutting, etc. Lasers are presently used successfully for a variety of applications in medical field, especially ENT. It means ear, nose, throat surgery As laser light can be concentrated into spots, the laser has found applications in surgery and other forms of treatment. Especially, it is a painless and bloodless surgery, then it has no side effect. Next, surgery is highly precise and localized. Also, it gives prompt healing and finally requires only short periods of surgical time, but it has highly expensive one. Additionally, it was used as military weapon. It is used as target designator and it is used in defensive applications. Thank you for watching this video. We will meet again in next video with one of the interesting topic. Thank you.